What's up, everybody? It's Miss Brothers. Let's go ahead and do practice 9. We're doing stoichiometric conversions where we're converting from the mass of one substance to another substance. So let's take a look at these problems, you guys, because what I need you to understand is the purpose of doing these conversions is we're trying to consider things or what it would take to do these in lab quantities. So all of these problems, you guys, relate to a chemical formula. So like this problem right here relates to this chemical formula up top. The problem with this chemical formula is that everything is given to us in quantities that are moles. Moles. And the problem with that is that moles are super gigantic, so they're not practical when we're dealing with something for lab purposes. So we do these stoichiometric conversions because it allows us to convert these massive quantities of these to more reasonable quantities. Instead of 2 moles, we're looking for something that has 25 grams of something, or 15 grams of something, or something like that. So that's why we take the time to do these conversions, so that we can take these massive quantities into something more reasonable that we could put together in a lab. Okay? So let's go ahead and work on this one. And now a couple of things. This problem says how many grams of potassium chloride are produced in 25 grams of potassium chlorate decompose. And what that means is you have this substance right here, and this, you guys, is potassium chlorate. And the reason that we know that this is a chlorate is because if we were to put parentheses around this, we would know that this is a polyatomic ion, and if we look at the back of our periodic tables, there it is, chlorate right there. It's ClO3. So again, you guys, what's challenging about this question right off the bat is to figure out what we're looking at. Potassium chlorate, potassium chloride, they basically sound like the same things. But this is a chlorate, and this is potassium chloride. So let's go with what we're given. How many grams of potassium chloride? So we're trying to find this. How many grams of this are produced if 25 grams of potassium, so that's KClO3, decompose. Okay, so this is a decomposition reaction. We have potassium chlorate decomposing to form 2 moles of potassium chloride and 3 moles of oxygen gas. Now, because we're eventually trying to get to grams of potassium chloride, we've got a little bit of things to do first. So right now, you guys, we need to get to this unit and this substance, and right now we're at the right unit, but we're at the wrong substance, so this is our next move. So our next move, you guys, is we have to get rid of this unit of grams of potassium chloride. So I'm going to go ahead and put that down here, grams of CaClO3. And again, you guys, the first thing we do is we have to convert everything to moles. So we're going to say 1 mole of potassium chlorate. Now, what I don't know right here is the quantity that I need to fill in here. And remember, you guys, if I have 1 mole of a substance like potassium chlorate, it means I have to figure out what's in it. So I know if I go over here, I'm just going to use this little spot over here, I've got some potassium, and specifically I have 1 atom of potassium. I have chlorine, and I have 1 atom of chlorine, and I've got oxygen, but I've got 3 atoms of oxygen, so I'm just going to put O3 right there. Now what I'm going to do is I'm going to use my periodic table in order to find these quantities. So I'm going to start with potassium. Here it is right here. And if I look down at the bottom of the square, this is the atomic mass, or 39.10. Now, if I'm talking about molar quantities, I can say that 1 mole of potassium has 39.10 grams of potassium in it. So that's what I'm going to write right here, 39.10 grams. I have to do the same thing with chlorine, so I'm going to come over here to my second to last column. I'm going to find chlorine, and I'm going to see that its mass is 35.45 grams, and that's what I'm going to write right here, 35.45 grams. And then finally, I have oxygen, and oxygen has a mass of 16 grams. But remember, I've got a subscript of 3, which means I have to take 16 times 3, and if I do the math on that, it's going to be 48.00 grams. And once I add all of these things together, my potassium plus my chlorine plus my 3 oxygens, and I end up with a mass of 122.55 grams. Now what this means is that 1 mole of potassium chlorate has 122.55 grams, or this thing weighs 122.55 grams, or it has a mass of 122.55 grams. So far so good, because now what we can do, we can cancel out these grams of, this unit grams of potassium chlorate. Now I have to be able to cancel out this unit of moles of potassium chlorate, because I need to finish up with this unit, which is grams of potassium chloride. Now I can't go from moles straight to grams, okay? I have to go through the process of finding the right molar equivalent first. So I have to be able to cancel out this unit, which is potassium chloride. So I know I have to put 1 mole. Actually, I'm not going to put 1 mole. I'm going to use my chemical formula to help me with this. Okay, so I have to, down at the bottom here, I know it has to be mole of potassium chlorate. And I'm going to use my chemical formula to determine how many moles. So if I go up here, I notice that I have 2 moles right here. And remember, I'm trying to finish with my substance of KCl, potassium chloride. I have to be able to find the number of moles of this first, and it turns out it's 2, because that's what's in my chemical equation. So in other words, you guys, what this means is that if I have 2 moles of calcium chlorate, it's going to break down into 2 moles of calcium chloride. So now I have enough information to cancel out my unit of moles of calcium chlorate, and I'm left with moles of calcium chloride. But I'm not quite done, because I have to finish with grams of potassium chloride. So I can set that up right there. And I know that I have to get rid of the unit of mole, so I'm going to put 1 mole of calcium chloride down here. And I kind of have to go through that same process that I did over here. But this time, instead of it being potassium and chlorine and oxygen, now it's just me adding the potassium and chlorine together. So I take 1 potassium plus 1 atom of chlorine, and I end up with 74.55 grams. And then I could go ahead and cross out my moles of KCl here and my moles of KCl here. And now it's just a matter of setting up my math. So I've got 25 times 2 times 74.55 grams of KCl over 122.55 times 2. As far as doing the math, I'm going to go ahead and multiply 25 times 2 times 74.55. So 25 times 2 times 74.55, and that equals, I'm just going to drop down here, 3,727.5 grams of CL over, and that's going to be 122.55 times 2 is 245.1. And then if I finish that out, 3727.5 divided by 245.1 equals 15.21 grams of potassium chloride. Okay, so that is number 1. And again, you guys, this process that we're going through is pretty repetitive throughout this entire worksheet. We take what we're given, we find its moles, we use our chemical equation to figure out our molar ratios between substances, the substance that we have or given and the substance that we have to finish with, and then we have to take that and we have to convert it to whatever unit we have to finish with. It's either going to be grams or it's going to be liters. It could even be particles or molecules. It depends on what the problem is asking us. All right, let's go to number 2. Now, in number 2, I want to know how many grams of hydrogen are necessary to react completely with 50 grams of nitrogen in the above reaction. Well, let's take a closer look at what we have. We have nitrogen, in this case it's diatomic nitrogen, or nitrogen gas. We have 1 mole of that because there's no coefficient, which means it's the same as saying 1 mole. Right here we have 3 moles of hydrogen, or diatomic hydrogen, which is hydrogen gas. And these things synthesize, and they end up forming 2 moles of the substance ammonia. So when you see NH3, you know that that is ammonia. And guess what? It's a polyatomic again. And you can find it on the back of your periodic table. So let's go ahead and set this up. We know that we start out with a given of 50.0 grams of nitrogen. And remember, you guys, nitrogen is N2. If all else fails, you guys just go back into your chemical equation and look and see how nitrogen is written. It's written as N2. I know that I have to be able to cancel out my grams of N2. And I know that I need to convert it to moles of N2. And again, what I need you to remember is, let's go back over here. We have diatomic nitrogen. If I look on the periodic table, nitrogen has a mass of 14.01 grams. But remember, this is N2. So that means I have to take 14.01 times 2, and if I do that, I end up with 28.02 grams. And so that's what I'm going to write right here, 28.02 grams, and I can go ahead and cancel out my grams of N2. And now I have to be able to get rid of this unit, moles of N2, and I can do that by going back into my chemical formula because I'm doing equivalencies between the nitrogen and the hydrogen. So if I have, in my chemical formula, I have 1 mole of N2. And what that means is that if I want this reaction to happen, I need 1 mole of N2, but I need 3 moles of H2 to go with it if I'm going to get this quantity of ammonia. Now this is working out well for us because look, you guys, the final substance that I have to end up with is hydrogen, and here's diatomic hydrogen right here. And it also means that I can go ahead and I can cancel out this entire 1 mole of N2. So here I am with my proper substance, but I don't have my proper unit yet. My unit is moles. I need it to be grams. So I need to be able to figure out how many grams of hydrogen are in 1 mole of hydrogen, of H2, diatomic hydrogen, or hydrogen gas, which means I have to go back to my periodic table. Here's hydrogen on the periodic table. It has a mass of 1.01. If I have 1 mole of H2, it means that I've got 1.01 times 2. So H2 is another way of saying 1.01 times 2 is 2.02 grams. So that's what I'm going to write right here, 2.02. That is not very well written. 0.02 grams of H2. And now I can go ahead and I can get rid of the unit of moles of H2 here and here, and the only unit I have left is grams of H2, which is exactly what I need to end up with. So I'm going to take 50.0 times 3 times 2.02 grams of H2 over 28.02. And if I do the math on that, I'm going to end up with 50 times 3 times 2.02 equals 303, and we're going to divide that by our 28.02, and that equals 10.81 grams of H2. Excellent. Now, we're going to stay with this problem, or I should say we're going to stay with this chemical formula right here. Because now what we want to know is we want to know how many grams of ammonia are produced in the reaction in problem 2. And remember, you guys, the reaction in problem 2 starts with 50 grams of nitrogen, so that means that's exactly where we're going to start in this problem as well, with 50 grams of N2. It's just instead now of solving for hydrogen, we're solving for ammonia. Now the first part of this problem is exactly the same. 1 mole of N2 is the same as saying 28.02 grams of N2. It means that if I weigh, or if I can find a way to put a mole of nitrogen gas on a scale, it's going to read 28.02 grams. So now I can go ahead and cancel out my grams of N2 here. Remember last time where we did our molar equivalencies with 1 mole of N2, and we used hydrogen last time. We used that 3 moles of H2. That's because we were trying to solve for hydrogen. This time we're not trying to solve for hydrogen. We're trying to solve for ammonia, which means I have to go back and I have to find how many moles of ammonia are in my original chemical equation, and there were 2 moles of NH3. So now I can go ahead and cancel out my mole of N2 there and my mole of N2 there. And I'm getting closer because now I have the correct substance that I need to end with, which is ammonia, but I don't have the right unit yet. My unit is moles, and I need grams. So I have to go 1 mole of NH3 down here so that I can cancel this and cancel this. But before I do that, I need to find what my mass is in grams of NH3. So I'm going to go over here because what I remember is that nitrogen, all by itself, has a mass of 14.01 grams. And look, this nitrogen is all by itself. And I have hydrogen, but I have H3, because remember, that 3 only affects that H right there. So that means I have my mass of hydrogen is 1.01 times 3, which gives us 3.03 grams. And if I add these two things together, I end up with 17.04 grams. Let me double check my math on that. My math is solid. So that's what I'm going to fill in right here, 17.04 grams of ammonia. I can cancel out my units or moles of ammonia, and then I can set up my math, which is going to be 50 times 2, there's that 2 right there, times 17.04 grams of ammonia NH3. And underneath that, I'm going to put 28.02. So if I do my math on that, I've got 50 times 2 times 17.04 equals 1,704 divided by 28.02 equals 60.81 grams of NH3. So what that means is if I react 50 grams of nitrogen and 10.81 grams of hydrogen, I'm going to end up getting 60.81 grams of ammonia. Huzzah! Okay, let's move on to number 4. Number 4, we've got a new equation. What we have is we have 2 moles of silver nitrate reacting with 1 mole of barium chloride. It reacts, it's a double replacement reaction. We end up with 2 moles of silver chloride, and we end up with 1 mole of barium nitrate. So let's go ahead and go to our problem. It says, how many grams of silver chloride are produced from 5 grams of silver nitrate reacting with an excess of barium chloride? This is sort of extra information. It's not really important for our problem, so as far as this excess of barium chloride, we're going to kind of ignore it for right now. Okay, so we need to figure out how many grams of silver chloride So this one right here, how many grams of silver chloride are produced from 5 grams of silver nitrate, which is this stuff right here, okay? So let's go ahead and set that up. 5.0 grams of silver nitrate, AgNO3. And nitrate, you guys, is one of those polyatomics that we can find on the back of our periodic table. And like all of these problems, you guys, this all starts out by converting this to moles. So 1 mole of AgNO3, and we've got to figure out how many grams of AgNO3 this is. So that means we're going to have to go to the periodic table, because we've got to, so what we have to do is we have to add all this up, the silver and the nitrogen and the oxygen. So let's just kind of go over here and do that. So we know that silver is Ag. We're going to go to our periodic table and we figure out that silver has an atomic mass of 107.87 grams. We have nitrogen. We already know, based on the work we've already done, that nitrogen has a mass of 14.01 grams. And we know that if we've got 3 oxygens, like we do right here, it's going to be 48.00 grams. And if we go ahead and add that up, we end up with a mass of silver nitrate. So 1 mole of silver nitrate has a mass, or it weighs, 169.88 grams. Well, the good news is we can get rid of this unit of grams of silver nitrate here, and we are on to the next. We have moles of silver nitrate here. We need moles of silver chloride, because silver chloride is where we're going to end. So we're going to go ahead and put that right here. 1 mole, actually not 1 mole, just mole of silver chloride. We don't know how many moles yet because we haven't really looked at our problem. Let's look. Looks to me like right here we have 2 moles of that. That's how we're getting that 2. And if we've made 2 moles of silver chloride, it means we had to start out with 2 moles of silver nitrate, so AgNO3. This gives us the ability to cancel out our moles of silver nitrate here, and we are nearly done. Because right now, you guys, we have moles of AgCl as our unit, and what we need is grams of AgCl as our unit. So we're going to go ahead and we're going to put 1 mole of silver chloride right there. And we're above that, we're going to put grams of AgCl right there. We can cross out our moles by moles of AgCl. But look, we have to get this number right here, which means we have to go back to what we know already. So we know that, and I'm going to go ahead and bust out my calculator right here so you can kind of see where I'm getting these numbers. So I've got silver with a mass of 107.87 grams plus chlorine, because that's what the Cl is. And if we look at this, we know that chlorine has a mass of 35.45, so that's what we're going to do, plus 35.45 equals 143.32 grams. And I have my correct units, and I have my correct substance, so I'm ready to go ahead and start mathing this out. I'm going to math this out with 5.0 times this 2 times this 143.32 grams of silver chloride, AgCl, over this number, 169.88, times that 2 right there. And if we crunch all the numbers and do all the math, we end up with 4.22 grams of silver chloride. Hot dog. I like hot dogs. That's probably something you don't really need to know. I just think they're good. Okay, so like problems 2 and 3 earlier, problems 4 and 5 basically work the same. So we are going to stay with this chemical formula, but this time, instead of solving for how many grams of silver chloride, we're going to solve for how many grams of barium chloride necessary to react the silver nitrate in problem 4. So we're going to stay with this original quantity, 5.0 grams of silver nitrate, AgNO3. which is great because there really isn't anything different we need to do from this column to this column. We can just put the exact same thing in our column here. So moles of AgNO3, excuse me. We already figured out that the molar mass for silver nitrate is 169.88 grams of AgNO3. And we can go ahead and cancel out that unit of grams of silver nitrate. Sorry, you guys. My throat is getting dry. I'm going to take a quick sip of water. All right. So now we have to be able to get rid of this and bring in our barium chloride into the picture. And we're going to do that by using the molar mass of barium chloride in our original formula. And we have no coefficient, which means we have 1 mole of barium chloride. And because this third column is a molar ratio, it means we have to go back to our silver nitrate and remind ourselves that we have 2 moles of AgNO3. And now what we're in a position to do is we can cancel out moles of silver nitrate here and here. We're getting close because we know we have to finish up with grams of barium chloride. I've got the right substance. I've got the wrong unit. I have to finish with grams of barium chloride, which means I need 1 mole of barium chloride down here so I can cancel these guys. So I have to take a second and figure out what my mass of barium chloride is. I'm going to go back to the periodic table. I find barium right here towards the bottom of my alkaline earth metals, and it's got a mass of 137.33 grams. That's the barium. Of course, I've got chlorine, and we've seen that guy a bunch of times already. It's got a mass of 35.45 grams. And if I add those guys together, I end up with a mass of 172.78 grams. And if you're not sure, you need me to prove it. I've got 137.33 plus 35.45 is 172.78 grams. And I forgot to cross that out. I can do that. So now I'm in a position to just set up my math. I've got 5.0 times 172.78 grams of BaCl over this quantity right here, 169.88 grams times this little 2 right here. And when I'm done mathing that out, I end up with 2.54 grams of barium chloride. Right? So essentially what we're saying is that if I have 5 grams of silver nitrate and I react that with 2.54 grams of barium chloride, I'm going to end up getting 4.22 grams of this silver chloride and some unknown quantity of barium nitrate, because we haven't figured it out yet. If we wanted to, we could solve for the barium nitrate too, but we are not going to do that today. All right, you guys, that's it. That is stoichiometric practice, converting between the mass of one substance to the mass of another substance. It is practice number 9.